Hello guys, this is Cyprien from FEA for All, and in this video we'll do together a tutorial, a CFD tutorial in which I will show you how to simulate the fluid flow inside a manifold. And what will be interesting is that I will go from 0 and I will show you how to create the manifold geometry inside midas NFX and how to extract the fluid flow. So let's go for it. So let's create a new project. So 3D millimeter, okay. And now I have nothing. So how to create the manifold from 0? Well, I have my own methodology. Of course, there are a lot of possibilities of how to do that. But let me show you how I would proceed for this kind of project. So first, let's draw a line. So you have to be aware, of course, of the shape of the manifold you want to draw. So in my case, there will be an angle like that. There will be line here. There will be line here. And I will have an arc. So I'm first drawing the skeleton of the manifold. And that will be a wire. And then I will draw the section and then I will sweep it around to create the manifold. So okay, so now I have the section in this plane. Now I have to change the work plane in order to create the section in the other plane. And here you see it's a bit short, so I have to define and change the grid to something bigger. Oh, sorry. I keep the same size, but I will use user define, okay, to increase the number of squares like that. Great. And now let's see, I want an angle like that and then draw another line. So let's draw the arc. Okay, this is the wrong direction, so I have to do it again. Okay, so now I have a wire which is in this, well, actually it's not a wire, it's a segment, so I have to create the wire. Okay, let's select like that, apply. Now I have a wire in blue. Okay, now I have to create the other part of the manifold, which is not in this plane, so I have to find a way to create it in another plane. So the way I'm doing that, I'll show you. I'll move the work plane, select this, and select the origin of this point. So I first move the point to this, then I'll change the view in the side. And here I will draw some point where will be the center of the other branch. Okay, it will be here. And in order to create to do a plane that will go through this point, I need a second point. So I will translate this point in this direction. Okay. In the opposite way, like that. Okay. Oh, sorry, I have to copy it, not to, because I want 2 points. Copy, minus. Okay. Okay, now that I have that, I can move the work plane with 3 points. Sorry about that. Okay, I use the 3-point option. 1, 2, and 3. So I have to select well. Okay, this point here. I can do preview to be sure it will be okay. It will be in the right direction. Okay. So here I'm creating the manifold like that. And now what I have to do is basically to create the arc like I did for the first manifold. So I'm selecting, oh, I got it in the wrong direction again. So depending on the angle of your plane, your process might be slightly different, but no, it's almost the same. Okay, now I have to branch and I'll create another wire like that. Okay. Now that I have that, I can move the work plane again to this point here. Okay, and I can create the section for my manifold. So I will change the size to 10 mm for the grid, and let's do it like that. So remove make face option. Okay, so that's around the side of the diameter, and then let's make a face, and now it's ready to sweep. So let's just use the command sweep and the guide, and here I am. So here I have the first tube. Now I need the two other tubes on the both sides. So how to do that? And after there will be the tricky part will be how do I merge together those tubes. So let's select the plane again, so this one with the origin at this point here, and let's create another section like that, and let's sweep it. Okay, now I have also to create the internal section, and you'll see why right after. So let's create a circle here. Let's hide this first. Okay. Okay. And now let's view the model in the tree. So let's hide the surfaces, the points and everything, and also the grid. And I can display. So now let's mirror these two on the other side. This and this. Mirror this plane, and let's copy that. Okay. Now, how do I cut that? Because now I have three tubes, but they are not connected. So in order to do that, there will be a two-step process. First, I will need to use the Boolean operation to cut the shape of the main tube inside this one. And I will not delete the tool. Okay, so now I have this, and I still have my main tube. And do the same on the other side. Okay. Now let's see what we have. We have the main tube. So if I show only that, so there's no hole inside this. And then, okay, this. So this one we can delete it. So I'll delete the part that I don't need. Okay, and then so we have the main tube, and then we have parts like that which connects to the main tube, but there is no hole in the main tube. So that's why I created these internal, let's say, volume from here. And now I will simply cut again inside the main tube. I will cut those parts, and here I will delete that. So I can even select cut the two. Okay, and now I have, you see, a hole that is going through, and I have the two branches. So I have my manifold, and now the last thing I have to do is to fuse and merge the faces together. Okay, I have it. So now to do the CFD analysis from that, I have to create the internal CFD volume. So in order to create the CFD volume, I have to create surfaces at all of those ends. So let's display again the grid, and let's move the grid. Let's move the walk plane here. Okay, and just let's use the function circle in order to close those entries. Okay, like that. That's right. And now the last one. Moving. Okay. And let's close it. Okay. Now to create the volume, I need to know what is the approximate size of this. So let's just measure that. So let's say in this direction, yeah, it's around 1 meter. So I guess that if I do 1 meter, 1 meter, 1 meter, it should contain all that. So you have to go in geometry, and here you have others, make CFD volume extraction. So click on that, then you select the solid, you select the surfaces here, and now you have to include this volume inside a cube with the right dimension. So let's try that. Seems to be wide enough. And now I can hide the external volume. I can hide this, and I get the internal flow volume. Okay, so we're almost there. So let's save that. Now let's go for the simulation part. You can say the fun part. It's not so difficult to do that. So basically, first let's create a material, fluid, and I want water in 25 degree. Enter. Okay, I got it here. I have to assign a property to that. So CFD property fresh water, that's it. And let's mesh this domain. Let's check the size. It's much too big. Let's say 10. Sounds okay, at least for the first try. And I have to inactivate the option higher order elements, which are not used in fluid simulation. Okay, and let's just mesh it. Okay, I got my flow volume meshed. Now I have to assign the CFD boundary conditions. So let's do that. Okay, let's assign an inlet of 5,000. 5 meter per second in this inlet, and this one I will assign a 7 meter per second, and in this one 10 meter per second. And at the outlet I will use pressure 0 outlet. So pressure 0, okay. And now the last condition is to assign a wall around the fluid. So let's select everything and then unselect the outlet and the 3 inlets. And I have the choice between different types of wall conditions. If I choose a no slip condition, it means that the velocity at the boundary will be 0. But in this case, I need a boundary layer to analyze that, so to have a good enough accuracy around the boundary. But if I used dimensionless wall distance applied, it will use a function to estimate the viscosity around the walls. So I will just use that. It will be much faster. Okay. And basically now the only thing I have to do left is to do the analysis itself. So I have I will also monitor the result at the end. So there is a monitoring option here, so I can choose a node at the end, at the outlet, and monitor the velocity here, so I know exactly when it converges and when the velocity reach stable value at the outlet. And then I have just been steady or transient, so I'll do a steady state analysis. Okay, CFD 1, and basically analysis control. I have, let's increase number of iteration to 5, and that's all I have to change. And now I'm good to run the simulation. So let's wait a few minutes. So now you can view the graph. So this graph indicates the convergence, and you can see if the curve here goes below 10 minus 3, it means that I'm getting the convergence. So usually I only get the convergence after a lot of steps. At the beginning it always requires some time to stabilize itself. So it will require several iterations in order to go under this. See, now it went into the convergence zone, but it's still oscillating a bit. So how do I know I'm getting the convergence? Well, basically everything depends on your mesh, of your boundary condition, and a lot of factors. So it's very difficult to assess exactly how you can get the convergence every time. But what is sure is that there are a lot of ways to assure that you get a good model which will give you accurate results. But I won't talk about that right now because it's quite difficult. Okay, I'm getting more and more close to the convergence. So now basically I just have to wait for more steps in order to view the solution. So let's wait a few minutes more. Okay, and in the meantime you can view the velocity here, which is monitored. So you see that it's starting to reach a stable state, and even if the solution is not finished, we can always load the results like that. You do a right click, reload the result file, and you will be able to see the steps. So here, let's move that. I can view the current state of the fluid flow. This is not the final solution, it's just temporary solution which may be not totally converged, so that's why we have to be careful, and usually we have to wait much more before looking at the solution. But for this tutorial anyway, it's just to show you how to do this stuff. So, and now you can use the plane like that in order to view the state of the flow inside your manifold. And if you want to see vectors or flow lines, you can also do that like that, fluid flow path, and basically just select the nodes here and you will be able to view the flow inside. Can even animate that. It doesn't bring much, but it's fun to see. Okay, that's it for this video tutorial. So I'll just stop this over here. I hope you enjoyed it, and if you want to know more about FEA analysis, CFD, and even a lot of other things, just go on my blog feaforall.com and subscribe to the newsletter. I will send you new videos, updates, useful stuff, and I'll try really to send you the best things I have several times a month. So thank you very much for watching, and have a great day.